Hi, this is problem 9.6 and we like to find the centroid of this plate. We could use either a vertical strip or a horizontal strip. Important is that whatever you use the proper integrals, right? Let's use a horizontal strip to describe my area. So this will be dy. And this here, as you see, this point over here describes x. Therefore, this yellow thing that I mark will be 1 minus x. Therefore, my differential of area will be 1 minus x dy, which is the base times the height. I need to calculate the area of that plate. Therefore, the area will be the integral of my differential of area. And since I chose to use a horizontal strip, then will be 1 minus x dy. And the limit of integration is from my variable of integration, which is y in this case, which will be 0 to 1. 0 to 1. And if I put x in terms of y, x is equals y squared, then I have y squared dy. And I integrate that polynomial and I get y minus y cubed over 3. All that evaluated between 0 and 1. This is equals to 1 minus 1/3, which is equals to 2/3. So the area is equals to 2/3 meters square. So I was able to find the area of that plate. Let's now find the centroid. The definition of centroid will be equals to the integrals of the centroid of that differential of area over the total area, and my y will be the centroid of the total of that differential of area divided by the area. And I already found the area. So let's start by the x-coordinate, and we have, as you see, the location of my differential of area is right here. Where is that located? So we have that this will be x, and this will be here 1 minus x divided by 2. So I have to add those two values. Let me do it over here. Let me do it first over here. So my x will be equals to x plus 1 minus x divided by 2. That will be 2x plus 1 minus x divided by 2. That gives me x plus 1 divided by 2. This is the value that I'm going to plug in here. So x bar will be then the integral of x plus 1 divided by 2 times my differential of area. My differential of area is this one right here, 1 minus x dy. And the limits of integrations will be from y, which is 0 to 1 meters. And I have to divide that all. Let me write that integral correctly here. Divided by the area. And the area is 2/3. Okay, so I have here a 2 that I can take out of the integral. So that will be 3/4. And my integral will be from 0 to 1 meters. And this I can write it as 1 minus x squared, right? Well, factorization, you recall, and dy. And then this is 3/4, 1 over 1 meter, and I substitute x in terms of y, and I have that x is equals to y squared. Therefore, this will be 1 minus y to the 4th dy. Now I integrate, and I get 3/4 y minus y 5th over 5, and all that evaluated, and that gives me 3/4 1 minus 1 over 5. At the end, my solution is 3/5 meters. This is the location of my centroid in the x coordinates or the x-axis. Now we do the y-axis. Y will be equals to the centroid of my differential of area, and as you see, the centroid of the differential of area is located right here, right? So it's located at y. So I actually, it's much easier, I don't have to do anything. So it's from 0 to 1, y, and my differential of area is 1 minus x dy, and all that divided by the total area, which is 2/3. So that integrals become 3/2 integral 0 to 1 meter. Y minus x in terms of y is y squared, so therefore this is y times y squared, that gives me y cubed dy, and that's 3/2 y squared over 2 minus y fourth over 4, and all that evaluated in 0 to 1. And then if I evaluate that in 1, it gives me that the centroid, it will be located at 3/8 meters. And that's the location. So if we draw again our plate, right, x and y axis, my centroid will be located at 3/5, more or less over here, 3/5 meters. This is 1, and at 3/8 meters. And this is the solution of this problem.